Okay, let's go. Number 8. This is part 2. So, it continues with more trigonometry. Use the angle sum or difference formula to simplify the given expression and find its exact value. That's the key. Find the exact value. We'll talk about that. So we look at this, we try to match it, and we can see cosine, cosine minus, sine, sine. Cosine, cosine minus, sine, sine. So this is what we need to do, cosine of u plus v. So our goal is to go cosine of u plus v. Remember, u is always the first thing, v is the second. So we get cosine, 95 and 25 is 120. Now we'd be done if all it said was simplify. But it says find the exact value, which means spin that spinner, 90, stay somewhat accurate, por favor. 90 and 30, which means this is 60. Make it look 60. It'll help your brain, because this is 30, making this 1, but don't forget the negative. This is the square root of 3, and this is 2. So what's cosine of this situation? Adjacent over hypotenuse, negative 1/2. Now, could you check it with your calculator now? Yes, but in my class, I need to see this work for understanding. So here we go. Let's match this formula. Sine cosine minus cosine sine. Sine cosine minus cosine sine. Looks like we got a match. So we need to use sine of u minus v. First one's u, second one's v. Plug it in. So we get 151 minus 16. I'm guessing that is 135. Almost had a meltdown there. Okay, now we got to find it because of that. So we take our little spinner, we go 90 and 45, which is halfway. Finish the triangle. I know this is 45, 45, 90, so this is 1, 1, square root of 2, but this is negative, which wouldn't be important in this case because the sign, which is opposite over hypotenuse. So we get 1 over the square root of 2. Get that square root of 2 out of there. So we get the square root of 2 over 2. That is the exact value. All right. All right, let's do some graphing. So this says graph one cycle. And the first thing I'm going to do is remember that my cosine parent function goes over the origin. So that's going to look like this. I personally like to go a little bit left of the y-axis, a little bit right of the y-axis. Not everybody does, but I do. This is my letter A. Absolute value of A is 2. So it's going to pump that amplitude up to 2. I'm going to go ahead and make this dotted, and that negative 1 would dip down to negative 2. Notice I went through the 0 because 2 times 0 is 0. And then I go through there, and I go through there. So my amplitude was simply doubled. Vertical stretch. Now we got some problems, Houston. I don't know what you want to do first, but we're going to focus on this, and I'm going to take care of this right now. This is my A, this is my B, C, D. So I'm going to use multiple colors so I don't lose you here, but we're going to take care of this guy because it's in this formula. That's where that goes. The normal period is 2 pi. Remember, from pi to negative pi, and we're going to divide that by 2. So 2 pi all over 2 gives me pi. Don't forget, my initial period was 2 pi. Pi over here, pi over here. So the whole thing was 2 pi. So half of it is pi, half of it is the other pi. Well, now the whole thing is pi. So I need my walls to go from pi over 2 to negative pi over 2, because now my whole period is pi. Well, I'm going to try to squeeze this into this little tiny window. There it is. And now we're going to move on to this, my letter C. Well, minus tells me I got to move it to the right, pi. So I got to take this whole thing Remember, pi in this drawing is 2 units. So this is going to go 1, 2. This spot right here is going to go 1, 2 over. This spot, which is just up here, is going to go 1, 2 over. This spot right here is going to go 1, 2 over, which is over here. And if I haven't screwed this up, it's going to look something like this. And the final thing I'm going to do, and let's grab a color that's a little more vibrant, orange, and we got to bump that whole thing up 1. So this is going to go up here, this is going to go up here, this is going to go up here, and my final 1 period is right there. And again, that thing would keep going and going and going and going and going, but they only wanted 1 period. All right, let's move on to the next one. All right, so this time our parent function is sine. We know that goes through the origin like this, up to 1, back to 0, down to -1, back to 0. And there's your parent function, y equals sine of x. Let's take care of this easy peasy, lemon squeezy. 3, 1, 2, 3. So that goes up to here. That goes down to -3 right here. And I'm going to make this dotted. And there it is with amplitude 3. Now here comes a little curveball. There's my b. I got to put that here. So I have a 2 pi divided by pi over 2. Let's show my work over here. 2 pi all over pi over 2. Now here we go. Luca, you're going to be mad at me. He likes to turn these into radians, so it's 1, 2, whatever. I like to stick with this, so I'm going to take that, multiply by the reciprocal. I see that this flips. 2 times 2 is 4. For what? 4 radians. Wait a minute. What's 1 radian? 1 radian is approximately 60. It's actually closer to 57. But now we know 4 radians is 240 degrees. 4 times 60. Therefore, half of it is 120. Which if we just look at this, there's 90 plus 30. Whoopsie. Little mess up there. Oh no, I was on track. 90 plus a third is 120, and then I need to go the same distance over here, and I'm going to stick with the same program here and just use pink for my new walls to capture this with amplitude 3. So I got to go down to -3, back to 0, up to 3, back to 0 in a shorter amount of time. So that's a horizontal shrink or compression. But we're not done. We still need to bump this thing right 3. Right 3 what? Radians. Well, if 1 radian is approximately 60, 60 times 3 is 180. I think I got you on this one, Luca. 180 is just pi, which is very nice, because that means I just need to move this 180 degrees to the left. Well, 180 is 2 chunks, so if I added 2 of these, I would know this would go to here and to here. And I'm going to make my new wall orange. And then this guy would move 1, 2 to here. And then I would just try to redraw that. The middle of this would be a little bit of a stinker situation, but give me a second. All right, I just had to make sure my mind was working right. But I'm choosing this to be my middle because it looks like my middle, but it looks like I got 1 1/3 this way, and I got 1 1/3 that way, so that's my middle, which is a nice target in this situation. So I'm just trying to duplicate this pink guy, and here, here, and here. Just bumped it left 3. Then for the grand finale, I got to move that whole thing down 1. I don't even know if I have space, but anyways, that would go down to here, that would go down to here, that would go down to here. I'm just going to draw that in before I forget what I said. That would go down to here, and that would go down to here. And that's close to the right answer. Perfect? No. Pretty close, though. All right, so the infamous high tide, low tide problem is back, and rather than so YouTube kind of fights me. It's hard to upload videos if it's longer than 15 minutes. It just takes forever and a day. So I'm going to make this part 3. It'll be the last problem we do in this review. So I'm going to skip it and get to it later. So let's dive down to these quicker problems. Let's factor this. So the first thing we're going to do is look at both of these and ask, what can we take out? And then what's left? Well, 6 and 54, I can take a 6 out. I got 2 x's here, 4 here, I can take out 2. Well, what times this gives me this? Well, that would be x squared minus 9. Now we're like, okay, we're done. Be careful, that's a difference of 2 squares. When it says factor, there's an implied rule completely. So you need to recognize this and go, wait a minute. Thank you, Algebra 1 and pre-algebra and Algebra 2 teachers. That's a difference of 2 squares. X minus 3x plus 3. 6x squared. Now I've factored that completely. Let's go to this one. Now there's multiple ways to attack this, but we normally love it when this is positive. So what we're going to do, we can't multiply this by a -1. If this was negative x squared plus 16x minus 39 equals 0 and the instructions were solve it, then you would multiply it by a -1 simply because you can. This is not an equation, this is an expression. So we have to deal with it the way it is. But one little thing we can do is factor out a -1 from everything. And then just ask ourselves, are there 2 factors of 39 that add up to -16? Now this is a new looking one, but yeah, 13 and 3. So x minus 13 and x minus 3. And that's as far as you can go. All right, we're going to just tackle matrices now. So here we go. Write impossible if they're impossible, but find the answer if they're not impossible. Well, add A to B. Well, here's A and here's B. Now, in order to add, this is a 2 by 3. This would need to be a 2 by 3, and it's not. So this is impossible because they need to be matching matrices. Let's go down to here, 3C. Well, I just triple everything here. So as long as I don't make a silly mistake, which I'm capable of, -21, 27, 9, -24, and you can stick a fork in that one. C times D. Well, remember, we're going to multiply C's row by this column. There's 2 things in this row. There's 2 things in this column. So we're good to go. Now I got to do some mental math. 28 plus 63. I'm going to write that down. 28 plus 63. Can't make a silly mistake. 91 in the upper left-hand corner. But then I got to hit this row with this column. -14 plus 45. -14 plus 45. That's 31. And that would go here. You go right across the top. This is the top column or top row, and then your answers are going to go through the top row. So, and then we got to go through this column. -7, 0, 0. 9 times -3 is -27. And if I make a silly mistake, please reach out to me and I'll fix it. And then we got to dip down to this one. 3 times -4 is -12, and -56. So -12 and -56 is -68. So that's down here. Then I got to go 3 times 2 is 6, and -40, that'd be -34. That one's easier. 0 and 24 gives me a 24. So that's how you multiply. A little bit of a pain, easy to make a silly mistake. D minus A. All right, so I've got D, and I'm going to rewrite this. 4, whoopsie, -4. That's how easy it is to make a silly mistake. And I'm just kind of bringing D on the left, because that's where I got it from. And then I'm putting A on the right, so I can visualize what I'm doing. I am not a right-brainer, so I got to see what I'm doing. Now it's easy. All right. What's -4 minus 1? -5. What's 2 minus -3? 2 negatives make a positive. 5. What's 0 minus 1? -1. 7 minus a -2. 9er. 5 minus 0, 5. -3 minus 5 is -8. All right. I think I'm going to pause this video now because we're up to the 15-minute mark, and I better stop right now. See you in a second for part 3.